Okay, here's an example where you're supposed to find n of t, that's the null space, and r of t, the range, as spans of polynomials, where the linear transformation is given from p3 to p2 by taking the first derivative, multiplying by 3, and adding on the second derivative. So t of f of x equals 3 times f prime of x plus f double prime of x. So we have to find all that. We'll work in the standard bases. And so that means what we first need to do is plug in the standard basis on P3 to t. So we'll find t of 1, t of x squared, and t of x cubed, which happen to be 0 because the first and second derivatives are both 0. 3 because the first derivative is 1 times 3. Second derivative is still 0. Then x squared turns into 2x times 3 is 6x, and the second derivative is 2. And x cubed turns into 3x squared times 3 is 9x squared plus 6x. Then we write each of those four as columns, and we have to look and check and see where our outputs are. They're in P2, so we should write them as columns of size 3, since P2 has dimension 3. So that'll be 0, 0, 0, 3, 0, 0, 2, 6, 0, and 0, 6, 9. Now we just got to solve the problem. That matrix times a vector x is equal to, or we'll say maybe a vector of constant c is equal to 0, 0, 0, the homogeneous matrix problem. The solution to that will give us n of t, but meanwhile we'll be able to look at the pivots and find r of t as well. So row reduction goes pretty fast. I just divided through by 3 on the first row, 6 on the second row, and 9 on the third row. Then I used the second row to get rid of that 2/3, so I'll get a negative 2/3 above the 1. And then I used the third row to get rid of both the 1 and the negative 2/3. So my row reduced echelon form just has a column of zeros, so that'll be free, and then 3 pivots. So the free variable, I'll call these the 4 variables are C1, C2, C3, and C4. Free is C1. Then the rest of them are all not free. They're equal to 0. So C2 is 0, C3 is 0, and C4 is 0. 1 for each column. So to write the answer as a span, this is the answer is all the vectors that get sent to 0. So that's the null space of t. So it's the span of, and this written as a vector is that C1, C2, C3, and C4 are equal to anything times, or C1 times 1, 0, 0, 0. So the span of 1, 0, 0, 0. Almost finished because it said to write this as a span of polynomials. But remember, this is in the basis. You have to look at the input basis since we're talking about the null space. So we look at the input basis. That's why there are 4 components to that vector, because the input is P3, and the basis that we're using is the standard basis. So 1, 0, 0, 0 is just 1. It's the 1 times 1 and 0 times x, 0 times x squared, and 0 times x cubed. So it's the span of the function, the constant function 1. All right, that does actually make sense. You can take the derivative of 1 or the second derivative of 1 give you 0. So plugging in another constant multiplier times 1, like 7, still derivatives of constants are 0. So to get the range of t, we look back and see that we had 3 pivots. So we take the 3 columns from the original matrix, which are 3, 0, 0, 2, 6, 0, and 0, 6, 9. And they are in P2. So we turn those into polynomials: 3, 2 plus 6x, and 6x plus 9x squared. So the nullity of t is equal to 1. In this case, there was a vector in the span 1, 0, 0, 0, which was non-zero, and so it has a dimension 1. And the rank of t was equal to 3. And that means that it actually is an onto transformation. The rows of the matrix are linearly independent. There's a pivot in every single row, so it turns into an onto linear transformation.